All right, so maybe you've seen a headline that says something like only 5% of the ocean has been explored, or that we have better maps of the surface of Mars than our own seafloor, which is also true for Venus, by the way, but it never gets the press. The point is that we still know relatively little about our oceans, especially the deep sea, and that means that what I do, seafloor mapping, is a field of primary exploration and sometimes exciting discovery, like the glass sponges of British Columbia. That's a species that we thought was extinct, long extinct in the neighborhood of about 100 million years, until a seafloor mapping exercise identified some anomalies, prompted researchers to send down cameras. And I love that story. It's part of why I got interested in this field of research, because if an extinct species was living in our backyard the whole time, what else are we missing just by not looking for it? So I study seafloor habitats, and I'm interested in the impact of climate change on marine species. Right now, we know that marine species are shifting their ranges faster and further than animals living on land. And we know that at a global scale, in general, fish are moving into deeper water and towards the poles, trying to maintain their thermal range as the ocean warms around them. However, when you zoom in and you look at a regional or a local scale, that relationship falls apart. There's more to it that we don't quite understand yet. We don't know if climate change is pushing these animals into habitats that they can occupy with appropriate food, shelter, or intense competition. So that's the question that I'm asking. What is the role of seafloor habitat in climate-driven range shifts? And to answer that, I need much better maps of the seafloor. The problem is that mapping anything that's under hundreds or thousands of meters of salt water is a tricky task. It's well beyond the reach of light, and so instead of using imagery, like from satellites or aerial photography like we would on land, we use sound. We emit a pulse of sound from a research vessel, and by measuring the delay, the angle, and the strength of that echo, we build three-dimensional, high-resolution visualizations of seafloor that no human has ever seen, and perhaps never will see, which is incredible and also extremely expensive. And so you can imagine that we've mapped very little of the seafloor in this way. That's your 5% from the headlines. The thing is, fishing vessels are on the water almost all the time, and they're also collecting depth data. It's just that that information is rarely used for scientific research. What I've done is taken crowdsourced bathymetry from fishing vessels, used geostatistical interpolation to build a continuous map of almost 700,000 square kilometers of the Newfoundland and Labrador shelf. That's what you see on the slide. And then using that information about the depth and the shape of the seafloor, information on seabed type, the location of species found in research trawls, ocean temperature and salinity, I'm looking at the changes in ranges of key fish species on the Newfoundland shelf since 1995. And then by looking at the relationship between a species, their habitat, and climate change in the past, I'm hoping to improve how we predict into the future, so that when we build our sustainable fisheries management plans, our conservation plans, our marine protected areas, we're building them in a way that includes and acknowledges the dynamic nature of marine ecosystems. Thank you.